Hey guys, welcome back. We are on to lesson 4, 2D and 3D shapes. I would like to take a moment to ask you guys to watch this first video. This video kind of describes what a cross section is. A cross section is when you slice the image and then you're looking at the shape that was created in the slice. So go ahead and take a look at that video and then we will continue with the lesson. So, 2D and 3D shapes. Now that you've watched that video, let's go ahead and look at all this stuff I'm going to fast forward, you guys. All of this stuff that we're going to fast forward. 3 of the things that we need in order to be able to do this lesson is we need to remind ourselves of some volume formulas. So go ahead and write on your notes, volume formulas. And I hope you have your notes titled 2D and 3D shapes because that will obviously help you for your notebook check. So the first volume formula is a rectangular prism. Rectangular prism. What that means is we've got a rectangle and then it's stretched back to make a three-dimensional situation. Some people call this a box. Some people call this a box. I like my box to be filled with chocolate, so that's what I'm gonna imagine. It's a chocolate box. Okay, the volume formula for a rectangular prism is going to be the length times the width times the height. Length times the width times the height. There's rectangular prism. The next one, we are going to learn sphere. Now a sphere is like a ball. It's a circle that's been spun around to make a 3D shape. So it's like a ball, maybe a beach ball, a basketball, a soccer ball, I don't know, whatever kind of ball you want. I like to think of it as maybe like a lollipop because I'm always hungry. All right, so the volume for a sphere is going to be 4/3 pi r to the third power. So I know pi r squared is the area of a circle. So just change that squared into a third power and then just put a 4/3 out front. There's the volume of a sphere. R is your radius there. So R is the distance from the center to one of the edges. That's my radius R. The next volume we're going to talk about is the volume of a cylinder. And I know I'm going kind of fast over these because you guys learned these in math too. So a cylinder is like is a circle, and then you take that circle and you stretch it upwards, and then it's going to create a cylinder. I like to think of it as like a can of soup or a soda can because once again, it's food related. So that is a cylinder. The volume of a cylinder is simply the area of the base, which is a circle. So R is the radius of the circle. That is a circle. The area of the base, which is a circle, times the height. So you take the area of that circle and just times it by the height. And that's the volume of a cylinder. We also do need to remind ourselves of some areas. So we just need to remind ourselves what the area of a circle is. So areas, fuzzy wuzzy was a bear, circle area is pi r squared. My husband taught me that. He said he learned it in like middle school or something, and he remembered it all the way until now. Fun fact. Okay, so that's the area of a circle. We also need to remind ourselves how to find the area of a rectangle. I don't know why I wrote it over here, but whatever. Rectangle, area equals base times height, or length times width, or one dimension by the other. All right, circle, rectangle, and triangle. Triangle, area equals 1/2 base times height, because a triangle is a rectangle that's been sliced diagonally. Poof. So there are your areas. Now, what I'm gonna do, you guys, is I'm just going to go to the quiz and do all the quiz questions, but my dog's barking, so I gotta let him out. I'm back, and I know that was like 0 seconds for you because this is a video. So, In this quiz, question 1, a cross section is cut from the cylinder below. That means that this cylinder, this can of soup, was cut directly down the center. And the question is asking, what is the shape of that cross section? So what I want to challenge you guys to do is to find something in your house that is cylindrical, which means is the shape of a cylinder. So I'm gonna grab a can of soup. I grabbed cocktail peanuts. Oh my gosh, and of course it's like ginormous. Okay, so this is a cylinder. See, it's a circle and then it gets tall, all right? When I look at this two-dimensionally, what figure do I see? If I were to cut this directly down the center, what figure do I see? And if I put this on paper and I trace it, this is like my best artistry ever. Okay, what does that kind of look like? It kind of looks like a rectangle, right? So if I were to slice this right down the center, that's the exact shape that I'm gonna create. I'm gonna create a rectangle. So the shape of the cross section here would be a rectangle. All right, next up, a hemisphere is cut along the plane shown below. A hemisphere is simply a sphere cut in half. Hemi means half, I'm assuming. Hemisphere, half of a sphere. So this is a hemisphere, it's cut in half. What shape is that going to create? Well, my good rectangle, here's a sphere. Here's a hemisphere, half of that crap, right? So a hemisphere is gonna be like this. Oh, this is not a good drawing. Anyway, I'm gonna cut this. So I'm gonna cut this directly in half, which will create half of a circle. So it's gonna be C. It's gonna create that little situation looking right there, C. All right, a rectangular prism cut along the shaded plane shown below. So rectangular prism, this is our box of chocolate. We're gonna cut it diagonally using this little shaded plane. So one thing that I try to do when I'm looking at this, when I'm looking at these, is I try to say how many corners are gonna be created in that slice. So if I'm on the corner of a rectangular prism, I see a corner there, a corner here, and a corner here. So I see that there are going to be 3 corners created. Well, what shape has 3 corners? A triangle. So that's the shape that's going to be created. Sorry, they're out of order. Please be diligent when you're picking your answer. That's the shape. Next. Okay, I'll let you guys do that one on your own. Next. All right, let's look at this. What is the area of a circular cross-section of a cylinder that has a height of 10 inches and a diameter of 6 inches? So what is the area of a circular cross-section of a cylinder? So let's draw our cylinder. You know, our can of peanuts, our can of soup, our soda can. Okay, there's our cylinder. And there are a few different types of cross-section that you can create in a cylinder, but a circular cross-section means it's just gonna slice it directly parallel to the base. So if I were to slice this to create a circular cross-section, it would be directly parallel to the base, which means that that cross-section is gonna be exactly the same size as the base. That's what that means. So it says the height is 10, and it says the diameter is 6. If the diameter is 6, what's the radius? The radius is half of that, so 3 inches. Now the question isn't asking me what shape it's gonna make. It's obviously gonna make a circle because it's a circular cross section. The question is asking, what is the area of the circular cross section? So I have to remind myself, well, it's gonna create a circle, okay? I know the radius of this circle is 3. And how do I find the area of a circle? Pi r squared. So I simply plug that 3 into R. So 3 squared is 9 pi, and because it's area, it's going to be inches squared, not cubed. Volume would be cubed, 3 dimensions, cubed. Area is squared, 2 dimensions, squared. So 9 pi inches squared. Notice that they didn't multiply the pi in, so they just left the pi out. That's fine. You might see an answer like that with the pi left out. You might see it as a decimal with the pi multiplied in. You might see it either way. All right. Let's look at, here's one I want. A rectangle has a length of 6 millimeters and a height of 10 millimeters. Find the volume of the cylinder created by rotating the rectangle about its length. Now, Meryl, what does that even mean, about its length? Let's draw this. A rectangle has a length of 6 millimeters. So this is the length equals 6 millimeters, and a height, let's draw this over, Meryl. I'm gonna draw it this way. Length of 6 millimeters and a height of 10 millimeters. Okay, there's my rectangle. Find the volume of the cylinder created by rotating the rectangle about its length. So this is my length. The length was the 6 millimeters right here. This is my length. And it's saying find the volume if it's rotated about the length. So what I'm going to do with this rectangle is I'm literally going to rotate it around and swirl it to create a cylinder. So this is what it's going to look like. So I'm going to have this, because obviously it's rotated around here. This part is going to come down here. This is going to come down here. This is going to rotate back here. Are you guys visualizing this cylinder? So it's going whoosh, whoosh, whoosh to create a cylinder. Now, when I look at this cylinder, I'm probably going to look at it this way because that's how I visualize cylinders. I know that the height of this cylinder is going to be 6 millimeters. I know that the radius of this cylinder is going to be 10 millimeters because that's the distance from the center to the edge. Now the question is asking, find the volume of the cylinder. So I have to look back at my cylinder volume, which is pi r squared times height. All I do is I simply plug in my h, plug in my r to this little cool equation, and then, or formula, and then I solve it. I notice in the answers that the pi is not multiplied in. So once again, I'm going to leave the pi out. So volume equals pi times r, which is 10 squared, times my height, which is 6. Well, what's 10 squared? Isn't that 100 times 6? Well, what's 100 times 6? Isn't that 600 pi? And because I was dealing with millimeters, I have to put millimeters there. Because I'm dealing with volume, it's going to be millimeters cubed. All right, if you guys have any questions that I didn't go over that you're struggling with, go ahead and shoot me a message. Try your best. Hope you're having a great day.